Hi guys, welcome back to next session. Today we are going to discuss about Gauss-Jacobi method. So this is also indirect method. So as I said earlier, in our previous class we discussed one more method in iterative, that is Gauss-Seidel method. So this is also another iterative method. How to solve this? What are all the procedure for solving this Gauss-Jacobi method? Let us discuss. First one, let the system of equations be a11x plus a12y plus a13z equal to b1, a21x plus a22y plus a23z equal to b2, a31x plus a32y plus a33z equal to b3 with diagonally dominant. I hope you maybe remember what is diagonally dominant. You may have the system of equations like that. In the first equation, the coefficient of x must be maximum. In the second equation, the coefficient of y must be maximum. In the third equation, the coefficient of z must be maximum. Suppose the given problem may not diagonally dominant. It is our duty to convert equation into diagonally dominant. Accordingly, we have to rearrange the given problem. This is the first point. Clear? Second one, the above system should write in the form of x is equal to 1 by a11 into b1 minus a12y minus a13z. That means here I assumed that a11 is the maximum value in the given equation. So keep it a11x in the left hand side, bring out remaining terms on the right hand side and bring out that a11 in the right hand side. Therefore, we get x value like that. Similarly, y value is equal to 1 by a22 into b2 minus a21x minus a23 into z, assuming this is equation number 2, and z equal to 1 by a33 into b3 minus a31x minus a32y, assuming this is equation number 3. So first I did my equation into diagonally dominant. From that I am finding x, y, z values. So this is the second point. Third one, we start the initial value x power 0 equal to 0, y power 0 equal to 0 and z power 0 equal to 0 for x comma y comma z. Through that we will get x power 1, y power 1, z power 1. So therefore equation number 1 comma 2 comma 3 becomes x power 1 is equal to. Actually, here I would like to tell one important point. What is the major difference between Gauss-Seidel method to Gauss-Jacobi method? So these both are iterative method, isn't it? So here for finding x power 1 value, we can take y and z becomes 0. And for finding y power 1 value, we should take x and z becomes 0. For finding z power 1 value, finding z power 1 value, we should assuming x power 0 and y power 0 is the assumption. So this is the major assumption. But in Gauss-Seidel, we did in a different way, right? So now come to this problem. Come to this third point. Equation number 1, 2, 3 becomes x power 1 is equal to 1 by a11 into b1 minus a12 into y power 0 minus a13 into z power 0. So first iteration of x value getting with the substitution of y power 0 equal to 0 and z power 0 equal to 0. Second one, so how will we get first iteration of y is equal to 1 by a22 into b2 minus a21 into x power 0 z power 0, right? Similarly, I am going to find out z power 1 value. For first iteration of z value, replace x is equal to 0 and y is equal to 0. So this is what the fundamental procedure for this method. Now step 4, using this x power 1 for x, y power 1 for y, z power 1 for z in equation number 1, 2, 3 respectively, we will get second iteration. So second iteration, if you want to find out second iteration of x, here you should replace y1 z1. Similarly, y power 2, you should replace x power 1 z power 1 value. For z power 2 we can replace x power 1 y power 1. That is the immediate values has to be replaced in the iteration. So this is the major difference between the Seidel method to this method. So this is what I am telling. Continuing in the same procedure until the convergence is confirmed. What do you mean by convergence? So that values should be equal up to third decimal, 5 decimal according to the problem. So you have to remember these procedures before entering the problem. Clear? Now let us take one problem. Solve by Gauss Jacobi iterative method. Correct to the decimal up to 5 up to 5 1 up to fifth decimal. The system of equations are x plus y plus 54z equal to 110, 27x plus 6y minus z equal to 85, 6x plus 15y plus 2z equal to 72. So as I said earlier, this is iterative method, or we can tell indirect method. So for this we should check whether the given problem is diagonally dominant or not. Is first equation is diagonally dominant? Obviously no, because here z value is maximum. Look at the second value, is y is maximum? No. So in the second equation x value is maximum. In third equation y is maximum. Therefore it is our first duty to rearrange the problem. So 27x plus 6y minus z equal to 85 has taken the first equation. 6x plus 15y plus 2z equal to 72 has taken as equation number 2. X plus y plus 54z equal to 110 is taken as equation number 3. Now from equation 1 I would like to find out x value. X is equal to 1 by 27 into 85 minus 6y plus z, assuming this is equation number 4. From 2 I am finding y value is equal to 1 by 15 into 72 minus 6x minus 2z, assuming this is equation number 5. Equation number 3 implies z value is equal to 1 by 54 into 110 minus x minus y, assuming this is equation number 6. Right? So first I did diagonal dominant. From that I am finding out x, y, z values in terms of y, z and x, z and x, y. Right? Now I am going to start iteration 1. Put the initial values x power 0, y power 0 and z power 0 equal to 0 in the equation, in the RHS of equation 4, 5, 6. Right? So here I am going to find out x power 1 value. So for the first iteration of x value, what we supposed to do? Replace y0 z0. So the equation becomes 1 by 27 into 85 minus 6 into y power 0 plus z power 0. Here I am going to replace y power 0 is 0 and z power 0 is 0. So we will get 85 by 27. Using calci we can simplify. We will get 3.14815 is the answer for x. Similarly, first iteration for y, what we supposed to do? We replace x power 0 z power 0. So that value is 0 here. So simplify that, you will get 4.80000. Now I am going to find out first iteration value for z. So for finding first iteration value for z, I have to replace x is equal to 0, y equal to 0, and we will get 110 by 54. Simplify that, its decimal value becomes 2.03704. Right? So I would like to move for second iteration. For second iteration, we have to take these values are initial values. So second iteration, put the initial values x is equal to 3.14815, comma y is equal to 4.80000, z equal to 2.03704 in right hand side of 456. So equation number 4, x power 2 is equal to what? For finding x power 2, I have to take y power 1 z power 1 value. Right? So what is y value here? 4.80000. Here what is the z value? 2.03704. Just simplify this by using calculator. We will get 2.15693 is the answer. Similarly, for equation number 5, For the second, these two indicating second iteration, don't forget guys. So 1 by 55 into 72 minus 6x1 minus 2z1. Replace x power 1 value and z power 1 value. That is, you are getting value for x and z from first iteration. Replace here and simplify. You will get a 3.26914 is the answer. Similarly, find out the value for z2. So for finding z2, we have to replace the values of x power 1 and y power 1 here and simplify this. We will get 1.88985 is the answer, right? So are these second iteration and the first iteration values of x, y, z are equal? Obviously no. Therefore, I supposed to move for third iteration. In third iteration, what will be the replacement? For finding x3, I have to replace y2 and z2 value. For finding y3, I have to replace x power 2 and z power 2 value. For finding z3, I have to replace x power 2 and y power 2 value. If you are substituting these, we will get x3 value is 2.49167. Y3 value is 3.68525. Z power 3 value is 1.93655. And go for fourth iteration, x power 4. For x power 4, we have to replace y power 3 and z power 3 value. Through that, we will get 2.40093. Similarly, y power 4 getting 3.54513. Z power 4 getting 1.92265. Right? So again, these values are not equal. Therefore, I would like to go for fifth iteration. For fifth iteration, I would like to replace y power 4 and z power 4 value in x power 5. So we will get 2.43155 is the answer. For finding y5, I should replace x power 4 and z power 4 value and simplify these. We will get 3.58328. For getting z power 5, we shall replace x power 4 and y power 4 value here and simplify these. We will get 1.92692 is the answer. Now check this fourth and fifth iteration value. Is these values are similar? Because in my problem they are mentioning find the up to 5 decimal. That means after the decimal value of the 5 digit must be equal. Here not equal. Therefore, I have to move for next iteration. So sixth one. So x power 6 is equal to, replace y5 and z5 value. We will get 2.42323 and y6 getting 3.57046. Z power 6 getting 1.92565. Now again I would like to move for seventh iteration because the values are not equal. For seventh iteration, I have to take the values from sixth iteration. For finding x power 7, I is supposed to replace y power 6 and z power 6 value. It gives 2.42603. Y7 gives 3.57395. Z power 7 gives 1.92604. Again, I needed to go for 8th iteration. So these all substitution as becomes in equation number 4, 5, 6. Don't forget that. So x power 8 equal to 1 by 27 into 85 minus 6 times of y power 7 plus z power 7. Replace the values here and simplify that. You will get 2.42527. Similarly, y power 8 becomes 3.57278. Z power 8 becomes 1.92593. Again, these values are not equal. I have to move for ninth iteration. For ninth iteration, we can take the values of y power 8, z power 8 and x power 8 from the previous one. Here I need x power 9. Therefore, replace y8, y power 8 and z power 8 here. So this becomes 2.42553. Again, y power 9 becomes 3.57310. Z power 9 becomes 1.92596. Is these values are equal? Like you just check iteration 8 and 9. Obviously no. I have to move for next one, 10th iteration. So for 10th iteration, for getting x power 10, I have to replace y power 9 and z power 9 in equation number 4. It gives 2.42546. For getting y power 10, replace x power 9 and z power 9 in equation number 5, which gives 3.57299. For finding z power 10, we should replace x power 9 and y power 9 value in equation number 6, which gives 1.92595. Again, these values are not equal. Therefore, I supposed to go for 11th iteration. So, for getting x power 11, I have to replace y power 10 and z power 10 in equation number 4. We'll get 2.42548. Similarly, in equation number 5, y power 11 value is 3.57302. In equation number 6 gives z power 11 value, that is 1.92595. Again, these values are not equal. I have to move for next iteration. Iteration 12. So for getting x power 12, I have to replace y power 11 and z power 11 in equation number 4, which gives 2.42547 is the value. For finding y power 12, I have to replace x power 11 and z power 11 in equation number 5, which gives 3.57301. Similarly, z power 12 value becomes 1.92595, right? So why I am going this much iteration? After decimal, 5 digit must be equal. That is what they are asking in our question. So here it is not equal. Therefore, again I have to move for 13th iteration. So in 13th iteration, what will come? I have to replace x power 13 value. For getting x power 13 value, I have to replace y power 12 and z power 12 value in equation number 4, which gives 2.42548. Similarly, for getting y power 13 value, we replace x power 12 and z power 12 in equation number 5, will get 3.57302. And for getting z power 13 value, I have to replace x power 12 and y power 12 in equation number 6. We will get 1.92595. Now look at the 14th iteration. For getting 14th iteration of x, I have to replace y power 13 and z power 13 in equation number 4 and replace the respective values and simplify this. You will get 2.42548 is the value for x power 14. Similarly, for getting y power 14, we have to replace x power 13 and z power 13 value and simplify that. You will get 3.57302. For z power 14 value, we have to replace x power 13 and y power 13 value and simplify that. You will get 1.92595. Now look at the x, y, z values of 13th iteration and the 14th iteration. These values must be equal, right? For example, look at this 13th iteration. X value is 2.42548. Here also 2.42548. Similarly, y value is 3.57302 and z value is 1.92595. Here only these values are equal after the fifth decimal. Therefore, the solution of xyz is 2.42548 and 3.57302 and z value is 1.92595. So this completes the problem. So this is a lengthy problem. Why I have taken this? If you are clearly understood about Gauss-Jacobi method, right? So it's very easy. So if you are going to find out of a 14th iteration, immediately you can take the 13th iteration of y and z. That is what the ultimate idea for solving this problem, right? Thank you.